Hi, welcome to the next video in our three-dimensional figures unit. Remember that up until now, we talked a little bit about vocabulary. We talked a little bit about the triangular prism. And today we're going to add to our repertoire of what we know by talking about something called the rectangular prism. So the next page in my note packet is going to be devoted to the rectangular prism. And I think you'll like the rectangular prism because it's going to feel comfortable and familiar. I'm pretty sure that in middle school or even in elementary school that you saw and are probably pretty comfortable and confident with the material on the rectangular prism. So first of all, what is it? Well, the rectangular prism is a prism where the bases are rectangles. And if you're having a hard time keeping up with me as I write, remember that in the video you can pause me, you can stop it, you can rewind it if you need to. So if I'm going too fast, just pause me or slow me down. So I'm going to say prism with rectangular bases. So the easiest way to think about this is like a copy paper box or a tissue box or some other kind of rectangular box. Now, the formula for finding volume, and remember volume is the amount of space inside something. The formula for finding the volume of a rectangular prism is going to be exactly the same as the formula for finding the volume of our triangular prism. We're going to do area of the base. And remember that in this instance, our bases are rectangles times the height. And remember that for our triangular prism, the variable that we used to represent area of the base was a large B, or an uppercase B, capital B, times the height. But watch this. This is really cool. Remember that for our rectangular prism, our base is in the shape of a rectangle. And the way that we find the area of our rectangle is to multiply length times width. So the area of our base is really length times width times the height of the prism. So now you understand a little bit more about that formula, volume equals length times width times height, and where it comes from. All right, let's jump into some examples. In example 1, I'm going to draw a nice rectangular prism, and the way that I do that is by drawing my two rectangular bases first. And I'm going to draw some nice, decent sized rectangles. No wimpy, wussy little prisms for us. And then just like I did with the triangular prism, I'm going to connect my front pieces to the corresponding parts on the back. And that'll give me a nice little rectangular prism, even for somebody who, like me, isn't very good at drawing. Let's go ahead and let's give our rectangular prism some dimensions. I'm going to make this 10 inches by 4 inches by 5 inches. Now I want you to notice and pay attention to the fact that these bases are in the shape of rectangles. Because those bases are in the shape of a rectangle, I can use the formula length times width times height. If those bases were triangular, I would have to use my formula where I multiplied the area of that triangle times the height. All right, so let's go substitute in. I've got 5 times 4 times 10. And when I use my calculator to multiply all that out, I find that the volume of this rectangular prism is 200. And I can either label this cubic inches, or I can label it inches cubed. Either one of those gets the job done very nicely. Excellent. All right, so one done, and that wasn't so painful. Let's go ahead and label this one in our notes, example 2. And again, I'm going to draw a nice size prism. Remember, no wimpy wussy prisms for us. And this one, I'm going to give dimensions of 2 3/4 feet by 6 3/4 feet by 5 3/8 feet. So once again, I'm going to pay careful and close attention to the shape of these bases. I notice that they're in the shape of rectangles, and because they're in the shape of rectangles, I can use that formula, volume equals length times width times height. Or in this case, 2 3/4 multiplied by 6 3/4 multiplied by 5 3/8. And unfortunately, the calculator is not really good about using or multiplying these mixed numbers. So we have a couple different options here. If you remember from elementary school or middle school how to change a mixed number to an improper fraction, you can do that. Personally, I think it's going to be easier to change the fractions to decimals and then let the calculator handle the decimals. So you might remember that the fraction 3/4 is equivalent to 0.75. And if you do, good, that'll save you a little bit of time. But if you don't worry. To change that fraction to a decimal, I'm going to come to my calculator and enter that fraction by doing Control and then the fraction bar. And then to tell the calculator that you want to express this fraction as a decimal, and this is very important, you're going to hit the Control button before you hit Enter. And as long as you hit Control before you hit Enter, it'll change the fraction to a decimal for you. So I can see that 3/4 has a decimal equivalent of 0.75. In this particular example, I also want to find the decimal equivalent of 3/8. So again, I'm going to enter the fraction 3/8, but before I hit enter, again, I'm going to hit Control, and it tells me that the decimal equivalent of that fraction is 0.375. So what I really want to enter into my calculator here is 2.75 times 6.75 times 5.375. So I think that some of this with respect to the fractions is as much about knowing how to use your calculator as it is about doing the geometry. So I find that the volume of this particular rectangular prism, or this box, is 99.7734375. And it's either cubic feet or that same value and then feet raised to the third power. Beautiful. All right, that one was a little tricky due to the fractions, but I think we're still doing great. We've got one more to do. And in this instance, we're going to take a look at a cube. Now, a cube is really just a rectangular prism having sides or faces that are all the same. So I'm a terrible drawer of the cube. I'm going to try to draw this cube where all the dimensions are the same, but no promises here. And you can tell it looks more rectangular than cube, but we're going to say that it's a cube. So we know that if one of the dimensions of the cube is 5 feet, all the dimensions of the cube are also going to be 5 feet. Which actually makes our job easy. Notice that these bases are still in the forms of rectangles because a square is a rectangle. It has all right angles. So I can still use my formula of volume equals length times width times height. But what's special in this case is that my length, my width, and my height all measure 5. So I'm going to get out my calculator again, and I'm going to multiply 5 times 5 times 5. Nothing special about that. My calculator tells me that this is either 125 cubic feet or 125 feet raised to the third power. And that, folks, that's the deal with the rectangular prism. Can't thank you enough for your time and attention. If you have questions, remember you can always shoot me an email. You can email Miss Andre. You can come to either one of our office hours on Mondays, Wednesdays, and Fridays from 10 to 11. And even if you just wanted us to shoot an email to say hi, we would absolutely love hearing from you. Like all of the other videos, you do have a Castle Learning that goes along with this video. And the Castle Learning is 10.3, called Rectangular Prisms. And I believe, too, that this is your last video for the week, so you are very close to being done with your work for the week. Congratulations on that. Till next time, folks, stay healthy, stay safe, stay well.